Hi everyone, thanks for joining. We had a slight technical difficulty, but we'll be starting in just a minute. Hi everyone, thanks for joining us today. My name is Tom Jenks and I'll be hosting your webinar. Before we get started, if you'd like to ask a question at any point during the webinar, you can enter it in the questions control of the webinar control panel. We'll then answer all your questions at the end of the webinar. So without further ado, I'll hand you over to Sven and Mireille.
Thank you, Tom, and welcome everyone to the webinar, Protecting Your Factory Floor from Cyber Attack. I'm Sven Hammacher, and together with Mireille Skutsi, CEO of Cybersplice, I will be leading you through the webinar of today. The webinar contains 5 topics that we'll be going through. First, Mireille will explain why OT cybersecurity is growing in importance. Then I will show you how a successful hack through a factory floor systems could look like. We will be showing how a cybersecurity service can massively reduce the threat of a successful attack, how the hack as showed during the webinar could be prevented, and we will be offering a brief self-assessment for your OT environment, for which a report will be shared afterwards. And at the end, there will be a moment to ask questions that we are happy to answer. And I will be giving the word to Mireille now.
Thanks, Sven, and good day, everyone. So why has OT cybersecurity received so much attention of late? OT networks are not new, they've been around for many years, but cybersecurity was historically not a major concern as these networks were isolated from IT networks and the internet through air gaps. So this meant that these networks were mostly only vulnerable to physical attacks, and this was managed through physical access controls to equipment. But what we saw in the last couple of years is that OT and IT infrastructure have converged, with OT in many instances sharing the IT network infrastructure, or at least being connected to IT networks. And this is really to satisfy requirements for big data, distributed sensor data collection, MES, ERP integrations, remote access, and so forth. So it makes business sense to connect or converge OT and IT. However, it's not without increased risk. Next slide, please. So when we connect or converge OT and IT, we are exposing OT to a number of new risks. Incident in IT cybersecurity incident, for instance, can spill over into the OT network and cause collateral damage. A good example of that was the WannaCry outbreak of 2017. OT networks can also be the subject of opportunistic attacks where adversaries who compromise the IT network pivot into the OT network through unprotected bridges. And then OT can be directly targeted to cause physical damage or changes to processes. And compromised OT systems can also be harvested in reverse attacks against IT. An example there again, the Mirai botnet of late. For targeted threats, though, OT has to contend with advanced, well-funded threat actors, which could include nation states, organized crime groups, and activists. OT networks are, however, not designed or they're designed with different objectives from IT systems. And it's important for us to understand these differences when defending OT networks. So IT security references the well-established CIA triad. You may be familiar with that. It stands for confidentiality, integrity, availability. And IT security says when these three attributes can be assured, we've got a secure system. So in IT networks, the focus is heavily slanted towards the confidentiality requirement. And this is due to privacy and data breach and intellectual property concerns. But for OT, that triad is flipped over. It's all about availability. Availability is king. And without that, process disruption can cause physical damage or even threaten human life in some instances. Next slide, please. So although we see that the security design objectives are different, both OT and IT share the same types of vulnerabilities, broadly categorized in those areas listed on the slide. Now, IT practices have become well adapted to manage these key vulnerability areas. However, those practices cannot be easily translated to OT environments. So throughout the webinar, I will contrast OT with IT as a frame of reference. So if we look at code vulnerabilities, for instance, in IT systems, we've become accustomed to automated patching, right? So systems keep on updating themselves to take care of security vulnerabilities. OT components, however, have a much longer lifespan than IT. Some of these devices have been in the field for 15 to 20 years, and they're not supported by the vendors anymore. So the patches simply aren't available. And even if they are available, patching means downtime, and that also brings the risk of potentially breaking the device if the firmware upgrade is unsuccessful, which would affect availability. And then looking at configuration vulnerabilities, if you think back 20 years, Windows XP out of the box, plugged into the internet, hacked in 5 minutes. Nowadays, if you plug your Windows 10 into out the box into the internet, it can live on quite happily. And that is due to a change in the approach. So instead of an open configuration, we ship with a secure configuration from the start. In OT, the interoperability and the large number of vendor products involved makes it very difficult to harden configurations. Once we start hardening configs, processes start breaking, impacting availability again. And then for identity vulnerabilities in the IT space, we have solutions like single sign-on, privileged access management, multi-factor authentication, and so forth. In the OT, identity and access management is very fragmented. Every device has got its own password store, and some of them even hardcode passwords that you can't change. However, the biggest challenge, I think, with OT security is insecure protocols. So over the years, we've replaced unencrypted and unauthenticated IT protocols with secure equivalents. For instance, SSH replacing Telnet, HTTPS replacing HTTP. ICS protocols, however, are for the most part unauthenticated and unencrypted. There's a lot of legacy involved there. If an attacker gets a foothold on the network, they can happily send instructions to a PLC, for instance, which would execute those. So a different approach is needed to protect OT networks and processes. I will now hand back to Sven for the next segment of the webinar.
Thank you, Marijs. And I will be showing you how a cyber attack on the factory floor could actually occur. As you know, operational technology enables modern society by delivering critical infrastructure such as electricity and water, managing complex transportation networks, delivering advanced healthcare capabilities, and regulating our environments. The importance of OT, however, also makes it an attractive target for a number of threat actors, nation states, hacktivists, organized crime groups, as well as competitors, disgruntled employees, and terrorists have focused attention on OT networks to further their own aim of control, disruption, sabotage, extortion, espionage, and theft. In the following demonstration, a competitor has targeted a fictitious pharmaceutical company in order to conduct industrial espionage to obtain details of a newly developed drug, as well as mess up the production process. The target for this hack is Hexatosin Pharmaceuticals. The objectives of the hacker are obtain all data on drug manufacturing and mess up their production process. What you're seeing right now on the screen is the Purdue model, a reference model for enterprise architecture. The bottom three blocks, colored green, yellow, and orange, represent the actual physical processes of the organization. The purple block represents the control systems, SCADA as example. The yellow level 3 block represents the demilitarized zone between the OT and IT. It air gaps both domains. This block is fairly new in the model. It is where both OT and IT converges. Level 4, the enterprise zone, represents the IT network as you know it today. And level 5 is the demilitarized zone between internet and the IT network of an organization. For the hack, let's consider a pharmaceutical manufacturing process with network level separation between the IT and OT networks and integration between the manufacturing execution system and ERP. In the Purdue model, as displayed, level 5 and level 4 represent the IT network, and level 0 until 3 represent the OT network. I will use this model during the hack for further explanation. The first step of the adversary is selecting a target that can be used to reach their goal. Professional networking sites like LinkedIn are a good medium to find targets. Simple search queries with company name and job title will narrow down the search, as you can see on the screen. Once the target is selected, the attack commences. An attack in this case is delivered through a Waterhole attack, responding to one of the engineer's posts on an industry forum. With a Waterhole attack, a hacker targets a website that is frequently visited by his or her target group and tries to find and use vulnerabilities in these websites to compromise the target system. The hacker then simply waits until the target visits the website like a lion waiting at a waterhole to pounce on his victim. As the engineer is working from home, his home network does not have all the protections of the corporate network. The attack succeeds without any alerts. The attacker shifts into the OT environment when the engineer next connects to the OT network over VPN. The attacker easily makes use of the convergence between IT and OT, level 3 of the Purdue model. Once inside, the attacker performs reconnaissance activities to determine the lay of the land. He uses Nmap, a publicly available port scanner and network discovery tool. Normally, a network administrator uses Nmap to discover what hosts are running with what available services on the network to map security risks. The adversary uses Nmap to find potential exploits. The hacker finds a data storing system running a dated and unpatched operating system, as well as a network-attached storage device on the OT network that is used to store backups of ladder logic, HMI screens, and historian data. The hacker finds its entrance on the control level, level 2 and 3 of the Purdue model. For the ones that are not familiar with the terms, a data historian stores data of processes that are running. This data is used later on to diagnose problems. Ladder logic is a programming language used for PLCs. In this case, the attacker compromises and connects to the data storage system and the storage device on the OT network, establishing a foothold in the environment. The attacker set up his backchannel. With a backchannel, a separate communication channel is set up for the hacker. In this case, the attacker is using a command and control backchannel tunneled through DNS, a byproduct of the mesh ERP integration. With a command and control backchannel, an attacker finds protocols on the system that he can use to command that system. However, backchannels can also be established using USB, acoustic, ultrasonic, electrical, optical, and other air gap jumping techniques. The information from the backup storage device is extracted over the command and control backchannel. On the screen, you actually see the data being extracted. The adversary has engaged subject matter experts in this case. The subject matter experts analyze the extracted data and devise an attack to disrupt the factory floor process. Be aware that hackers often do not only exist out of only one person on a computer screen, but have a well-developed supply chain, sometimes even consisting of a help desk, supporting to transfer bitcoins to the adversary to resolve ransomware or process interruptions. The attacker finally launches the attack by uploading tainted code to the PLCs controlling the production process, using the data historian as springboard. The factory floor has been compromised. If the attack is pulled off by also targeting quality control systems or making subtle changes undetectable by the quality control processes, an inferior product will be produced and delivered to market, damaging the long-term brand value of the drug. The competitor has achieved his objective. Now, how could such a scenario be prevented? ATS Enterprise Security and Cybersplice offer various practices, techniques, and services that reduce exposure to internal and external threats for OT environments. Now, Marais and I will tell you how we help our customers in securing their factory floor for cyber attack and how these practices would avoid the hack as just shown. About ATS Enterprise Security. ATS believes in an integrated, holistic approach, end-to-end security from boardroom to shop floor. We support organizations with protection against external threats and prevention of fraud and unintended accidents from within the company. Our approach is to look at security from a human perspective, allowing a balance between proper security and workability. Utilizing years of experience, we ensure continuity and workability without compromising on a high standard of security. ATS is knowledgeable in a wide spectrum of security domains. Having been active for more than 30 years globally, within more than 25 countries, we've become a trusted partner for smart digital transformation, and we continue doing so with our deep security knowledge by offering consultancy, professional services, and 24/7 support for various solutions. Our goal is to support organizations in realizing a security-oriented workforce, developing processes that enable organizations to protect its assets and be compliant to law legislation, as well as introducing technology supporting the realization of the defined security strategy. ATS Enterprise Security chooses to only partner up with high-value partners to support our customers in the best way possible. One of them is Cybersplice, about which Marais will tell you a bit more now.
Thank you, Sven. So Cybersplice, we're an established South African company and we're based in Cape Town. And our sole focus is on operational technology, cybersecurity. We've got a cross-industry and a growing customer base in South Africa, and we are actively expanding into international markets through our partnership with ATS. When we considered partner criteria, it was important for us to have a high confidence that the partner has deep OT as well as IT skills. As I mentioned before, the IT way of thinking cannot just be transferred into an OT environment. And we believe that ATS fits this criteria 100%. Next slide, please. So what does it take to secure OT networks? Gartner proposes some key requirements. I will take you through these and also highlight the challenges with implementing some of them in OT. The first of them are asset management. We cannot manage what we can't see. So this is a key requirement for both IT and OT network management and security. In OT environments, we often find quite comprehensive configuration management databases or CMDB systems. The problem with these are that they only tell you what is known. They don't tell you about nodes that are unauthorized nodes that are introduced on the network. So in the IT space, we've got tools like a rogue agent detection that perform active scans of dark space. So that's an allocated IP space in the network to detect these kind of devices. On OT networks, this is not desirable. Any type of traffic we send into the OT network introduces latency, and it's also got the potential to disrupt sensitive OT equipment. Then the next point that we need to look at is active anomaly detection and response. Once again, in the IT space, we've got things like SIM systems, log correlation, and of late, network traffic analytics. What these systems try to do is to establish patterns and alert to outliers to those patterns. Now, in IT systems, it is very difficult to really pin down those patterns because there are humans involved, and human behavior is often very erratic. In OT, we've got almost near deterministic behavior. So device A talking to device B every day, on the hour, on the spot. If something changes, it means there's been a change in the environment. So OT active anomaly detection is a very powerful tool in this arsenal. Looking at security management, this is where, that's number 3 on the slide, this is where security policies are really turned into security practice. Things like least privilege, role-based access control, monitoring, incident response, secure design, and so forth. The challenge here is that in many cases, these practices cannot just be implemented in OT networks. So we require alternate approaches there, such as vulnerability shielding if we can't apply vulnerability management, or offloading identity management and remote access to specialized systems. Then moving on to network-based protections. In IT systems, we've got concepts like security zones, VLANs, intrusion detection and prevention systems, content filtering, and so forth. So the Purdue model we've been referring to is an attempt to establish that same kind of thinking for OT networks. However, there's also a consideration in OT whether or not these protections should be provided at the edge of a network segment or at the core of the network. So the problem I mentioned earlier is if we only go for edge-based protections, once that perimeter is compromised, it's almost like hacking in the 90s on the OT network. The likelihood of success is almost assured. Then moving on to identity and access management, I mentioned that identities are fragmented in the OT space. We've also got challenges with how to provide remote access for external parties only to certain parts of the OT network. We have challenges with multi-factor authentication and so forth. And then when we look at endpoint protection, this is a very well-established IT security practice. But in OT, it is increasingly difficult, if not almost impossible, to do this because we've got a lot of single function devices in there, incapable hardware, battery power limitations, and also the risk of denial of service if endpoint software, for instance, recognizes valid traffic as an attack and automatically blocks it. So it's a real challenge for OT. So with Cybersplice, we use an approach we call near endpoint protection, where Cybersplice is a proxy and it provides the endpoint protection for OT nodes as close to the endpoint as possible. And we do this through the vulnerability shielding I mentioned, as well as monitoring for things like indicators of compromise at the communication layer. And then the last recommendation from Gartner is to look at IT and OT alignment. So IT and OT management and security comprise different skill sets, different approaches, different ways of thinking. And many organizations are also coming to terms with the new definition of responsibility areas for OT security. It's often shared between engineering, facilities, and IT departments. So it is important to have those responsibility areas well defined. Next slide, please. So There are a couple of OT cybersecurity solutions on the market. Many of them detect attacks after the fact. So they follow an out-of-band monitoring approach. They sit on the side and they monitor OT behavior, and they would alert on anomalous activity. So at that point, the attack is already in progress. Cybersplice is different. We actively prevent cyber physical attacks from happening. And we do this by creating an encrypted overlay network on top of the infrastructure network, and then redirecting all OT traffic through the overlay network rather than the infrastructure network. By doing this, we disrupt the kill chain for adversaries to exploit vulnerabilities. The vulnerabilities are still there, unpatched systems, code vulnerabilities, config vulnerabilities, but the attacker can't get to it, so he can't exploit it. So this is also one of the key elements that Gartner recommends that you ask of OT cybersecurity solution, and that is, what is the plan to transition from a mirror mode to an in-path mode? And I think the reason for this is that they realize that without taking an active part in this mix, we cannot change the risk profile. So that is why we've got a preferred in-path deployment. Next slide, please. So I'll finish by highlighting some unique benefits of Cybersplice. Firstly, as I mentioned, the ability to actively reduce risk in the environment. We've got two modes to facilitate this. The one is called in-path, which provides full protection for OT nodes. And then we've also got an edge mode. In edge mode, we mitigate the increased risk from human interactions with OT components. So inevitably, the biggest part of risk in an OT environment is the humans that are connecting to the environment. That is how the threats come in. That is how the anomalous activity happens. So in edge mode, we move these users out of the environment and bring them in a controlled manner. Then we are also cost conscious. We do not require a rip and replace of legacy infrastructure. There are some other options on the market that falls back on software-defined networking. However, that means that you have to go and replace infrastructure, which could be costly. We've got a smooth transition path for customers to move their OT network segments into the overlay network. So some industries prefer the out-of-band monitoring approach, for instance, critical infrastructure, electricity generation. So in those environments, we sit in as an out-of-band mode, monitoring the environment. However, if there's an attack, an active attack in the network, the customer can move to an in-path mode to mitigate and to recover from the attack. So Cybersplice also, we don't require reconfiguration of existing systems. And we've got an absolute focus on availability. There's multiple paths throughout the overlay network for devices to communicate. We've got redundant hardware options. It actually enhances the resilience of the infrastructure network. I will now hand back to Sven to discuss how Cybersplice is integrated in ATS managed services, and then we'll show how the previous attack is mitigated through this approach.
Thank you, Marijs. As ATS Enterprise Security, partnered with Cybersplice, we offer strong solutions and services. Successful protection of your factory floor can only be realized when you have a clear image of what vulnerabilities are present. That's why ATS offers a OT vulnerability assessment through our engagement services consulting. By plugging in Cybersplice in mirror mode, network traffic can be tracked within the OT environment, and potential vulnerabilities can be gathered, assessed, and proposals will be made by ATS how these vulnerabilities can be mitigated. We also provide implementation support of Cybersplice at our customers. What follows naturally after a vulnerability assessment is the introduction of security enhancements. Based on the vulnerabilities found, Cybersplice can be implemented tailored to the specific security needs of the factory floor. Edge or in-path mode will provide additional active vulnerability shielding. The strongest solution that ATS offers with Cybersplice is the manage mode, with which ATS monitors the OT environment 24/7. When a security event occurs, it's important that after detection you respond quick and effective. Let me show you how we as ATS do that. ATS OT Security Managed Services provides a dedicated managed service aimed on securing OT environments in the best way possible. According to our support model, ATS has different experts in place that are ready to provide security and operational support 24/7 for any deployment mode mentioned in the previous slides. A 24/7 service desk is available for our clients, at which issues and requests can be logged according to our follow the sun model. Our service desk will monitor the visualization dashboards, dispatch the logged issues and requests towards the engineers, and make sure that they are logged, assigned, and resolved. The first line support roles are filled by our analysts. They are available 24/7 according also to a follow the sun model to follow up security events. Following up means that they will investigate anomalies and liaison with our clients whether the anomaly can be explained from the business side. If not, they will immediately start with further investigation and threat hunting to determine the anomaly is of malicious intent. Our analysts will also provide operational support for our use solution when needed. The second line support role is fulfilled by our engineers. They are also 24/7 available on standby. They assist the analysts with threat hunting and investigation if the anomaly tends to be of a complex nature. They are well trained on both maintaining the application as well as security breach investigation. They will also provide a consulting role towards our clients about security enhancements in their OT environment through our solution, as well as operational support on more complex requests and issues. The third line support role is fulfilled by our architects, as well as our partner Cybersplice, providing the solution, upgrades, and patches. Our architects are trained to deploy the solution at our clients, as well as consult on expansion from an OT, IT, and cybersecurity perspective. Let's see how our managed service using Cybersplice could have actually avoided the OT hack, as we have just shown. Early detection in order to disrupt the kill chain is key. Cybersplice would recognize an attempted attack at a number of stages. When the compromised engineering system is connected to the OT network via VPN, behavioral profiling immediately picks up Reconnaissance activity. On the screen, you see the Splice dashboard. What lights up red are the indicators of newly found behavior and the probes initiated by the hacker. The exploit used in the lateral attack against the data historian triggers as an indicator of compromise. What lights up red on the dashboard right now is the intrusion detection of Cybersplice. A signature is found of an attack. Even though DNS queries used to tunnel the command and control protocol are a normal behavior expected to be seen coming from the data historian, anomaly detection would identify the unusual pattern as an outlier. What you see on the screen is the Cybersplice visualization of the OT network traffic and the outlier, the extraction of data via the data historian from the OT network by the adversary. Uploading ladder logic from the data historian would trigger as a newly seen behavior. On the screen, you can see the anomaly, the traffic flowing into the data historian and from the data historian towards the PLC. Early state detections allow for disrupting the kill chain before further damage can be done. The ATS analysts would already have detected the initial probing activities with Cybersplice by the adversary and alerted the client's engineering support manager. Cybersplice provides the audit trail and behavioral profile to confirm suspect behavior, and the client guarantees the offending system for forensic investigation. Severe damage to Hexatosin pharmaceuticals is avoided. No money loss, no reputational damage, and the quality of the products and the brand are safe. observe node behavior, activity at the infrastructure level, detections, investigations, and prevented attacks, including this hack, are shared with the Boardroom of Hexatozen Pharmaceuticals. A forensic investigation traced the control breakdown back to the engineering workstation, Waterhole attack, and inadequate work-from-home protection. Control improvements are made in the organization to prevent this from happening again. OT hack prevention starts with getting insight in the cyber-physical exposure of your factory floor. As ATS, we are going to share a self-assessment after the webinar that we are going to share by email afterwards with our participants, which will take about 5 minutes to complete. After that, a peer review with other participants will be made anonymously and shared in a report with which we hope to give insight in your own cyber-physical exposure to external threats. Tom, are there any questions that we can answer from our audience?
Hi, yes, there certainly are. So the first question that's just come in, is the protection there automated to break the link made by the hacker, or does it require manual intervention?
So I can take this question, thanks Tom. The demonstration we showed here is a splice deployment in mirror mode, which is the monitoring mode. So in this case, we would have to have an action based on early detection to stop the attack. However, if we move from a mirror mode into an in-path mode or even the edge mode, that attack would not be possible because the hacker won't be able to get into the overlay network. So in that case, there's no automated response. It's actually mitigated before it starts.
Okay, I've got another one here.
Yeah.
Sorry, is that right? Okay. If we had to take an OT device offline due to a security threat, could you guys help with implementing and configuring a spare?
I can answer this one. Yes, as ATS, we offer 24/7 support services that can cover multiple OT devices and systems. Our services can be tailored to cover your OT operation as well as security.
Great. Okay. What does a Cybersplice deployment actually look like on the network?
We've got various, I think we've actually got a slide for this one as well, if you want to share that, Sven.
Yes,
We've got
yes.
Various deployment reference architectures, and they basically determined by the organization's risk appetite. So the picture we're showing here is just trying to put the overlay network into the context of an enterprise network. It shows some of the components we use. We call them cloaks and supernodes. And we've also got a splice controller in there. You can see the parallel paths that I explained that enhances the resilience of the underlay network. But in effect, it's determined by the OT network design and whether or not the customer wants to achieve full separation from any IT infrastructure. So that can be achieved. However, we can also, depending on the industry, so for instance, smart city deployments where there's networks that shared between across a number of disciplines, we can also leverage some of the IT infrastructure network to be able to provide a cost-effective design.
Okay, now I've got a follow-up to the previous question of talking about automated break in the link when there's a hacker. In what circumstance then would you not employ the higher level of protection, that is, blocking the attacker rather than just detecting it?
So I'll take that one. Like I mentioned, there's different industry requirements and different industry appetites for in-path protection. We know that this is the way the world is going, because without being in-path, you won't be able to reduce the risk profile. However, there was an interesting exercise performed by the Department of Homeland Security in the US, I think it was about 2 years ago, where they simulated attacks on the electricity grid. And one of the things they found was that as soon as they tried to bat the attackers, they found the attackers, but as soon as they tried to counter the infection, it just kept on reappearing and reappearing. So what they ended up doing was setting up an overlay network to reflow the traffic into that overlay network. So I think the point here is that some industries prefer not to have in-path activity. However, they do want that kind of activity as a mitigation when under active attack.
Okay, and I've got one last question here. How do you make sure you have a swift response when a security incident happens?
I can answer this one. As ATS, we have a runbook ready that is optimized based on the security event that's occurring to efficiently perform investigation as well as mitigation. So for example, if just an outlier is detected, that will be a different approach than when we actually see an active intrusion happening within the OT environment. So based on every event that we detect on the network level, we will react as swift and effective as possible.
All right, and that's all the questions.
Then I would like to thank everyone for attending this webinar, and we will be in touch very soon. Thank you.
Thank you as well.